Hello, friends. Wanted to have kind of a syllabus day with you here today. Got my screen sharing on here, and this is the syllabus we're going to be using for our summer independent study. So I'm planning on, I think I've got a couple of students, Curtis and Joseph signed up. Curtis is taking the 4-level class, and Joseph is taking the 3-level class. All right, so no prerequisites, although for next year's algorithm class, they'll probably encourage data structures. I think both of you are probably familiar with data. Everybody should be a little familiar with data structures. And if not, this will be a great way to get familiar with that. So again, this is a directed studies class. This is not the algorithms class, but I'm using this class to help me get ready to teach the algorithms class next summer. 3 or 4 credit hours, depending on what the students wanted. The syllabus is a PDF. It's got a table of contents that has a link on the top left-hand corner of every page. A lot of this stuff is standard boilerplate. Office hours. This summer, I plan on working from my house a lot to limit exposure to the global pandemic and to other diseases and things like that. I've got my desktop computer from work here in my basement at my house. And so although I do have an office up in Stafford 320, I can make office hours by arrangement as needed. I do have an office phone number and an office mailing address. The easiest way to get a hold of me, though, is going to be email and telling me when you would like me to swing by or get on a Zoom meeting and do stuff face-to-face. There's even a way with Zoom that you can allow remote access to your computer. So if you need to run something, I can allow you remote access of my computer and you can run something on my computer. Or you can allow me to remote access on your computer so that I can help you fix some problem or something like that. Preferred time and method to contact me. Again, I think Zoom is going to work great. And we've got some good technology, good tools that we can use, and I think it's going to be okay. That being said, I'm flexible, and if you guys need me, I'm there for you. The catalog description for the class that you're enrolled in, it's a group study of a specified advanced topics in computer science, 1 to 4 credit hours. It's offered at the discretion of the department, has no prerequisite courses. However, what I told my department chair I wanted to do was I wanted to get ready to teach the design and analysis of computer algorithms. So that's what this course description is. Topics include asymptotic notation and analysis, big O, recurrence, relations, sorting, the quick sort and merge sort, searching algorithms, divide and conquer, dynamic program, basic graph algorithms, the greedy method, backtracking, and NP completeness. So the course list 2413, I make some comments here. Mathematical maturity is a nice thing to have. It's great to have experience where you don't get tripped up by notation and things like that. Not necessary. Like just know that there is notation, know that there is stuff that you can get tripped up on, and be willing to ask for help, be willing to reach out to the internet and things like that. Required textbook. Okay, so for this class, I have a pile of textbooks that I've listed. The one that a lot of the examples are out of is this Foundations of Algorithms. This is by Richard Napolitano, and this is the 5th edition. I don't actually have the 4th edition or any of the other previous versions, but this is the one that most of the examples come out of. What you'll see in the syllabus, this is one good option. This is Less Than a Pizza, Algorithms for Dummies. The list price on this is $30. I think you can buy used copies for less than that. Some of the problems that you'll see are actually discussed in your Java book. So this is the 12th edition of Daniel Lang's Java book, but 8th, 9th, 10th, 11th version, they all cover a lot of the same material. Another book where I've seen a lot of these similar problems discussed is in this book. This is the Discrete Structures book. So I know A lot of folks still have those lying around. I've got another algorithms book from Jones and Bartlett, and it's great. It's extremely well written. My reservation with this is a new copy is more than $200. Considering that my first pickup was less than this book, I'm not necessarily going to say, oh, and you can only pass this class if you have this book. There's a lot of this information out there in other forms. Two other things that I want to call your attention to. The modern version of this is on the 3rd edition. I think its last printing is like 2005 or something like that. This book is the standard. This is CLR. This is Corman, Laserson, and Rivest. There's CLR-S is like the 2nd and 3rd edition. Anyway, you can pick these up, usually less than $50, and they have a lot of good detail. You can find versions of this on the internet. This is a book that is well worth the money. However, you can see how thick it is. Little too much to cover in the summer semester. On the other end of the spectrum is this one by Jeff Erickson. And so it's just called Algorithms. And this one's open source. So any of the topics, any of the things that we've set out for in the semester, you can actually go out and grab this and should be okay. All right, so that being said, I don't actually say there is a required textbook, but there are chapters that cover each of the questions that I want you to address in this textbook. So if you were going to buy one, this might be the one that I would say buy, or just do Algorithms for Dummies, or don't do anything at all and see how it goes. So we'll get into you'll get to see what the questions are today, and you can make that decision on your own. All right, course policy. We're going to try something different. I've got 2 high achieving students that I'm working with as far as I'm aware. And so I like carrots, I don't like sticks. I want to try using more rewards for the behavior I like and have fewer penalties. The concept here is there are 8 assignments that I need you to complete. And I'm not going to get into any of the details of what I want to see in those assignments. But at the end of those assignments, what I want is a YouTube video that basically convinces someone that you got your money's worth for an algorithms class and that you know what you're talking about when you're talking about an algorithm. So I want you to be able to define the components of an algorithm. I want you to be able to evaluate the cost of implementing and using an algorithm. Now, that can be hardware resources, that can also be complexity of the algorithm, and that can also talk about how the algorithm is going to grow as the problem it is addressing gets bigger. I also expect to be able to make selections between algorithms based on correctness and performance. Listen, if you get an algorithm that is 100% correct and its performance is good enough, get on with your life. You got other things you got to worry about. So let's get into the nitty-gritty detail. So for the first week, I want you really focused on a divide and conquer algorithm. Now there's 2 that I want you to look at. We're going to look at 2 sorting algorithms. For the first assignment, students are asked to examine merge sort and quick sort. So these are 2 separate sorting algorithms. I want you to research the algorithms and then make a prediction about which algorithm will perform better. Now, one of the things, I don't say what data structure you use. And I do know that merge sort and quick sort, I think this is one of those situations where if you're using an array, one of them is going to work better. If you're using a linked list, another one might work better. That all goes into your research. Implement both algorithms in code. So I want you to be able to think about it. I want you to be able to write about it. But I also, at the end of the day, want you to be able to put your hands on a keyboard and be like, let's make this thing work. I want you to also take this a little further. I want you to create a fixture to use both algorithms on the same data set multiple times. So you've got one data set. You've got merge sort, you've got quick sort. You don't have, maybe you run the algorithm once, one of them runs really fast, the other one runs really slow. Well, it might be that the second one that ran slow happened at the same time Windows was checking for an update, or somebody was posting a YouTube video or something crazy like that. And that's why I want you to be able to be like, no, I ran this 10 times and 9 times out of 10, it takes this slow, or this is the fastest time that I ever saw for this one. This is the fastest. You make those decisions. Time how long it takes for each algorithm to complete the sorting task on average. Please use an input set large enough to provide data suggesting a clear winner. If it's neck and neck because you're using teeny tiny data sets, no one cares. And it doesn't teach you anything, and it doesn't show you anything. If it's neck and neck and your computer is running for half a day each and they're both taking exactly 1/2 of one day, okay, that's a little more interesting. And I would say that's a good time to call an audible and say, all right, is there something that we're doing wrong in our implementation? Because our research suggested that this one should be faster and this one should be slower. I want you to make a video where you explain the two algorithms and share your research. You present your data. So the general idea here is this is a standalone product. You could show this off to somebody in your high school, and when they get done, they could be like, okay, I understand what divide and conquer is. I understand what sorting is. I understand what a merge sort is, and I understand how a merge sort's different from a quick sort. That's the goal. You are making a training tool. And so if you're wondering about this evaluation style, if you're like, well, why can't I just do a program? Why can't I just answer a question? For me, this is a 4,000 level class. And at the 4,000 level, you need to be doing things to prepare you for a job interview. And one of the things that you need to be able to do is to explain an idea. Because if you can't explain an idea, or if you can't explain a problem, then it's going to be difficult for you to work on a team. And so that is the structure of the assignment. Make a video, explain what the problem is, explain what your research is, explain what your solution is, have some code in the video, show that your code works. Each video is a standalone product that it should help you practice for a job interview, should help you get ready to do a job. So the feedback and bonus cutoff date for this is June the 9th. So Monday through Friday, you work on, study a project, come up with a video. As long as you get the video uploaded to the Dropbox by June the 9th, I'll pop in on June the 9th at noon. I'll go in, I'll provide feedback, and I'll give you bonus points. You don't make it by then, you can still upload it whenever you want, upload it to Canvas. I don't think Canvas has the bandwidth to handle YouTube videos. I don't anticipate these being much longer than 10 minutes, but I'm not going to give you any of those details. I want you to make a decision about what works best for the project you've done. If you didn't do any research, if you grabbed code off the internet from somebody else and it barely runs and you don't want to show that off, you can get this done in maybe 3 minutes, maybe even less. If you did a lot of research and you're ready to write a paper at the end of this, then, give yourself time to give yourself credit for the work you did. All right, second assignment is a math problem. And so, So if you make the cutoff for the feedback, there is a possibility of bonus points. So I'm going to go through, I'll watch your videos, and I'll provide you some feedback. Critique your work, critique your algorithm, critique your analysis and stuff like that. And then for the things that I enjoy and the things I feel like you've done well, I'll give some sick bonus points out. That being said, if you don't make the cutoff, then I grade it pass-fail. And what that means is I'll circle back at the end of the semester when we're calculating grades, and I'll look. And if there's a video in there, cool, I'll watch it. If it covers the topics that we wanted it to cover, great, that's a pass. Even if some things aren't perfect, as long as you got the work done, we'll give you a pass, but no bonus points. And if the video is missing, or if the video, you're supposed to cover 2 algorithms and do a comparison, you did one algorithm and said, hey, it's pretty cool. All right, so that doesn't feel like it's strong of a pass. But if you only do that once, that's probably a pass. If you do that on every single one of them and at least half of it's missing, odds are the second one that you do that only half the work, it's going to be a fail. Okay, binomial coefficient is a calculation that can be completed using either the divide and conquer or dynamic programming. So what I want you to do is dynamic programming. So divide and conquer is one option. So you can do a binomial coefficient. And again, chapter 3 of this text actually has an implementation for divide and conquer for doing binomial calculation. So research the algorithm, make a prediction, research memory requirements, number of operations, and algorithm complexity. Make them both work in code. Use a text fixture, set them up, run them against each other to do the same task on the same set of data. And do it multiple times. That way it's not just a, oh, something weird happened. No, I want you to have confidence in your answer. This is what they call kind of a an academic or a textbook environment. There should be a clear winner and a clear loser. And you should be able to research that. You should be able to get it running. And you should be able to have data that says, okay, this is what we think. But you're working in a real world environment. And that's why you need to do these things multiple times. And again, same rules apply. Basically, you've got Monday through Friday to, really study it, work hard on it, and then sometime by about noon on the next Tuesday, I want you to have that video turned in. So that's dynamic programming versus divide and conquer. Then we're going to talk about an optimization problem. The knapsack problem is actually rather interesting to me. And so it's this concept of we're going to have a bank robbery, essentially, or a jewelry store robbery, and you go in, you can only steal so much stuff. You only have so much weight that you can carry in your bag. And the stuff that you're stealing has weight, but it also has value. And so what you're trying to do is figure out what's the most profitable way to rob a jewelry store. You gotta love scientific applications. This is somebody had a lot of fun with this, and this problem has been studied extensively. So anyway, I'd like you to take a look at two different approaches. One approach is the greedy one. The other one is this concept of dynamic programming. Look at those, figure out what works well, and your research should tell you this one should work better, and then your implementation should reflect what your research supports. Now, backtracking is another idea, and I want you to look at backtracking and dynamic programming and just compare those two. So hopefully this is a lighter week for you. Then I want you to, we're going to shift gears a little bit. There's something called branch and bound. Now, branch and bound is similar to backtracking. Anyway, you get a chance to work through that. Then we do a sorting and searching. And this is where we start to look at computational complexity. Every book that I have held up has a discussion about computational complexity. And in this one, let's see, I think it's the next one. Explain the two algorithms, share your, explain why this is an NP hard problem. So this is the bin packing problem, and it's known as an NP hard problem. Well, in your video, explain what an NP hard problem means. And then finally, for your last assignment of the semester, this is during finals week, you're going to do a reflection video. So I want you to do a genetic algorithm or a number theoretic algorithm, and you can do it on any problem that you like. I will tell you that one of the problems that I've studied a lot and really enjoy is called the traveling salesman problem, and I'm probably going to try to do an example on that. But I'm not going to limit you. I want you to go out and explore something that you enjoy. And then I want you to look at a lot of the same questions that you would have looked at on the other ones. Run time to perform the task, compare that to how you think that would have, how well does that match your expectations based on your research. Describe also in the video what you learned about algorithms, how this class has made you a better problem solver, the favorite thing you learned, and a project you'd like to go do next, something maybe you'd like to go back and revisit or something. And again, cutoff for that is July 23rd. Now, July, I think 24th is when final grades are due. I've got the course schedule up. Yeah, 23rd or 24th is when the grades are due. So as long as you make that, the class final is Thursday, July 23rd. So as long as you get it in by noon on the 23rd, bonus points and stuff like that. Grading criteria, I'm confident you're going to do really well in this class. And so if you're exceeding my expectations, that's probably going to be full credit. If you turn something in with your name on it, you're still going to get some credit. 88% is going to be the weekly assignments. And so we've got those 7, the 7 weekly assignments, that's 88% of the class. So each one of those assignments is more than 10%. Each one is basically a letter grade. The final and the reflection video is going to be exactly a letter grade. And then to encourage you to give course feedback, since this is something we're going to be doing next summer, I want to give 2% of your letter grade to course feedback. I anticipate that all students taking this class are going to do extremely well because these are my seniors and you know what to expect, you know how to manage your time. And so if there needs to be a curve, there could be a curve, but I don't anticipate really needing that. Lots of other fun stuff in here. One of the things that I wanted to call your attention to, listen, if you've got disabilities, anything like that, if you need special resources, whatever you need, I support that. And I want to enable you to be successful, and I'll go out of my way to help you be successful, whatever that means. One of the things that I wanted to talk about is my additional course readings. Now, I've had a lot of students give me feedback saying, you know, this has been really beneficial. Joy on Demand, fun little story there about that. How to win friends and influence people. I have a lot of people in business and industry telling me this is something that's important to them. The Clean Coder is the companion book to the Clean Code. And I've had a lot of students that have really enjoyed that. It's actually similar to the Joy on Demand. Best Year Ever is a wonderful book. Had one of my friends that survived cancer. And after that, he said, this is what's important to me. I want you to read this book because it addresses everything that goes into becoming a person. Getting Things Done by David Allen. I'm working through that again for I don't know how many times. It's a good concept, and it's also a LinkedIn learning video. Career Fitness Guide, C for Dummies, Java All-in-One for Dummies, C Programming Language. There's just a litany of books out there that are quite wonderful, and a lot of them are open source. Supplemental software, I had been using a lot of VirtualBox. This semester, I'm actually going to be using Hyper-V, and so this is something I've got Windows 10 or Enterprise here on this machine, and so I'm able to use Hyper-V and set up my virtual machine. Actually, what you're seeing on my screen right now is a Hyper-V terminal. So for this class, I also came up with something called a companion reading. For algorithms, the companion book is this little guy. Now, what does Extreme Programming Explained have to do with algorithms? Nothing. Okay, don't get confused about this. This is not a book that will help you understand algorithms. It may not even help you become that much better at programming. This is a book that helps you become a better human being. This is a book that says really simple ideas that you can do stuff with right now. So let's see. Here we go. So I present proven practices you can add to your own bag of tricks. No matter the circumstances, you can always improve. You can always start improving with yourself. You can always start improving today. So this is a book that if you read a little bit of it each day, this is kind of a schedule. Notice how the class starts on June the 1st, but actually the readings don't start till June the 8th. That gives you time to get a hold of a copy of it somewhere. The one thing I'll warn you is this is the second edition. The first edition, the difference between the two, Kent Beck actually did a video presentation about this. And the first edition, Kent basically said, if you're a programmer, you matter. If you're not a programmer, if you're one of those things like, you know, a boss, a manager, a company owner, you're basically useless. And it's amazing how off-putting that can be to people that write paychecks. And so Kent revised the second edition, and he said basically the only thing that lived from the first edition is the story about his mom teaching him to drive a car. And other than that, everything is completely rewritten. Anyway, we're using the second edition, not the first, and it's much more inviting to other people. And it says, software development needs everybody, including the people that write the paychecks. They're not just useless. So I try to break this up a week at a time. I'm also going to try to go out on the internet and put YouTube videos up that address all of these different things. But the book is something I would encourage everyone to read. Thursday and Friday, Independence Day, we're not going to worry about it for a couple of days. Have a good, nice weekend. Weekends you get off so you can catch up if you need to. And then we actually get done before the semester's out. So Friday, July 17th, I think we've got another week after that before the semester's done. I'm going to be trying to update my syllabus as the semester goes on. And whenever I've got notes, I'll try to put the notes in here. This in the preface, it said, no matter the circumstances, you can always improve. You can always start improving with yourself, and you can always start improving today. So anyway, that's my course syllabus. Again, to get a hold of me, email really does work the best. This is going to be more of a hands-off class. This is another one of those classes where you've got the opportunity to really showcase your talents and abilities and make a good case for why you need hired as an employee, why you need picked up for a research position, why you'd make an excellent candidate for graduate school, for the military, for whatever else it is that you want to go do. Or you can say, no, I have no interest in actually learning anything. I'm going to pay my fee, and then I'm going to try to do the bare minimum to get through this and BS my way through my YouTube videos, one YouTube video a week. And I'll say, you know what, you're going to get what you invest in this. And so if you invest significantly in this, you're going to have a great learning experience, and you're going to have a lot of opportunities to stretch your legs. Possibly this is where you try to pick up a new language. I know I've been trying to practice more with Python in this class for the examples for this class, because I haven't had a chance to practice with Python lately. But you can also take a more conservative route. Use a language that you already know. It's up to you. If you're already familiar with Python, maybe try doing this class in C. Whatever you want to get out of this class, whatever you're willing to invest, that's what you're probably going to get. So with that, friends, I appreciate the opportunity to work with everyone. And if you need anything from me, email me, give me a phone call, let me know. I'm here to help you be successful. I'm here to provide you an opportunity to showcase your talents and your abilities. I want to help you stretch, grow, and experience this in a way that makes sense to you. I'm not here to beat you up. I'm not here to make your life difficult. I'm here to provide you an opportunity to have an in-depth experience. I've got some minimum standards to meet, and I will tell you, I know most of the students that are taking this class. Actually, if it is just the two that I'm planning on, I know you both extremely well, and I know you'll both do extremely good work, and I have no reservations with that. But something goes sideways, we've got a lot of leeway, we've got a lot of wiggle room. So With that, friends, I'm going to go ahead and give you back the reminder of your day. I thank you both for your time. I hope you have a wonderful day. And like I said, if you need anything, please do email me. I'm very proud of you. I'm excited for the chance to work with you, and I look forward to seeing you soon. Thank you for your time. Have a great day.